The chi-square test of independence is a test done to see if two variables are independent. Usually, we are given a contingency table that the test is performed on. In this test, the null hypothesis, h sub 0, is always that the two variables are independent. The alternative test, h sub a, is that the two variables are not independent. A chi-square test of independence uses a contingency table to categorize data from a single group on two categorical variables. The chi-square test statistic is the sum of the square of the difference between each observed value for each cell in the contingency table and the corresponding expected value divided by that expected value. The expected value for each cell in the contingency table is the product of the row total and the column total for that cell divided by the overall total. The statistic calculated converges to a chi-square distribution with a parameter called degrees of freedom. The degrees of freedom, df, is equal to the product of the number of rows of the contingency table minus 1 and the number of columns of the contingency table minus 1. Let's use a chi-square test of independence to answer a question. 1,000 residents of a city were surveyed. The survey asked them to categorize their political views as conservative, moderate, or liberal, and to state their opinion about a proposed law. The findings of the survey are detailed in the contingency table. Are political views and opinions about the law independent at the 1% significance level? We need to perform a chi-square test of independence for these data. To start, calculate the expected value of each cell. Here are the calculations. Note that the rows and columns correspond to the contingency table. Now, add the expected values in parentheses below the observed values in the contingency table. Notice how the sums of the expected values in each row and column equal the total for the row and column. Now calculate the chi-square test statistic. Perform the calculations to find that the value is approximately 12.86. Now, determine the critical value of chi-squared. The table has 2 rows and 3 columns, so the degrees of freedom equals 2 minus 1 times 3 minus 1, which is 1 times 2, which equals 2. Next, look at the chi-square distribution with 2 degrees of freedom. The significance level is 1%, so locate the value in the row of 2 degrees of freedom and the column for 0.010. The test statistic, 12.86, is greater than the critical value, 9.210, so the p-value will be less than 0.010. There is less than a 1% chance of getting a similar distribution of data if the null hypothesis is true, so reject the null hypothesis. The last step is to interpret the conclusion based on the original question. At the 1% significance level, there is enough evidence to conclude that political views and opinion about the law are not independent.